Welcome everyone. Thank you for joining us today. Let's begin our session with a wonderful quote. Our future lies with today's kids and tomorrow's space exploration. Greeting of the day, good everyone. I, Yashika Malhotra, being your host for today's international webinar on topic application of space study in life. Extends my warm greeting and very good evening to all of you present here. As we know that studying celestial bodies help us understand the origins and evaluation of the universe, satellites enable global communication through telecommunication and broadcasting. GPS satellites provide accurate navigation and location services. Talking about SEMS Welfare Foundation, we are Section 8, not for profit company registered under the Companies Act 2013 with various recognition from Niti Aayog, MSME, MPCon, DDU, GKY, and more. Recognized as a startup by DIPP MCI and awarded Best Service Award for National Contribution, SAMES Group, with an active network of 5,000 plus professionals, published books, and international journal organized education and health camps for underprivileged children. Promoted digital and financial literacy and contributed to society. Our initiative, DigiSaksham, has developed content for 300 plus courses in IT, BFSI, retail, entrepreneurship, impacting diverse age groups. We have executed a skilling project for 600 inmates, signed MOUs for training, collaborated with various organizations, and conducted international conferences. Families, another SEMS initiative, empowers women through workshops and newsletter, conducting awareness programs in digital literacy, marketing, and career development across different industries. We have impacted over 1,000 women across states and recently celebrated a milestone of 100 women associated with the program. On behalf of the whole SAMES family, I welcome you all for today's international webinar on application of space study. And to add to our guest of honor, today's speaker is Sip Sankar Palit. It is a great honor to have you with us, sir. We are grateful for your presence here with us today. So he is the founder and is currently serving as the team executive officer of Life 2 and Beyond for the last 1.5 years. It's a young, dynamic, diverse, and inclusive space, non-profit based out of West Bengal, India, with a global community of young, enthusiastic, and professionals working in astrobiology, space studies, and application. He plays the role of coordinator of Space Crew Working Group of Innova Space UK alongside being its active member since its inception in June 2022. He is also a visiting scholar at the Blue Marble Space Institute of Science, US, currently working on a project related to the light detection knowledge base LDKB, an initiative of the M4 Research Coordination Network. Besides entrepreneurship, Palit has started learning about and doing research
Aspetta, Camandia.
and has been involved in active space science communication, event management, and outreach activities for the last 2 years.
Thank you very much, Yashika, for the wonderful introduction and quite a detailed one.
Thank you so
And thanks to SEMS Foundation for this wonderful invite, and most importantly, to the opportunity to discuss on this very important topic. Because generally, when we talk about space, it is something that we always relate to beyond Earth, or like not much relevant to our daily life. So, is space really a kind of thing that we should, you can say, worry about, or even is space technology applied to our daily life, or does it have even any kind of relevance to our daily problems? Not only that, the million or billions of you can say currency that we invest in space, is it even worth it when we already have so many problems here on Earth to solve? Right. So is it getting wasted? So to discuss all of these questions, I feel that this particular topic of applications of space studies in our daily life or life in general is quite important. Hello everyone, I am Shiv Shankar Palit, as already introduced. I think so. I do not require any other special mention for myself. Just that I'm obviously interested in chemistry and space and some other topics related to science communication, research, and entrepreneurship. But certainly, I will go forward to discussing more about that topic because it seems like the topic is quite interesting, and the talk is not about me, but rather the topic itself. So let us begin without further ado. I hope you all can see many faces on my screen of many known individuals like actors or comedian or like entrepreneurs or astronaut or like even the common people or professionals like the like our doctors or engineers or military officers or even farmers and all, right? Basically, putting their faces on my slide, I try to represent a diverse community of people that come from all across the globe. Okay. And this, and also it includes me, the common me here, as you can see my photo down there. But then the very particular line here that is quite important. The development of the nation, or as well as the world or the globe, is intimately linked with the understanding and applications of science and technology by its people. If the people don't understand science and technology, then who is making all the decisions? Right? Because at least in India or many other countries, we know that a democracy is there. The people choose the government, right? So if the people don't understand how science and technology is progressing, at least on a superficial level, even, then how will even the country or even the world progress, right? So this is something said by a very great individual from India only. Any guess from the audience? I would like to know in the chats if possible, while I go ahead, who said this particular line? Okay, I'll discuss that in maybe a few 10 seconds from now. So, if any guess from you all in the chat, like the name or part of his name, who said this particular line? My dear audience, please be interactive enough. If you can engage, it will be better so that we learn together. Okay, I see Abdul Kalam. Okay, not Abdul Kalam, but yeah, someone related to Abdul Kalam. He's quite of a popular face, like Abdul Kalam, I understand. So he is a person who was a mentor to Abdul Kalam. Okay, now you can understand perhaps who is he. He's none other than Dr. Vikram Sarabhai. Okay, a multifaceted individual in his own right and a charismatic personality. I think you can see already back there one of the ISRO's rockets. So, by without doubt, he is the father of the Indian space program, not just ISRO, but Indian space program. Even there are private organizations coming up, so it would not be right to just mention ISRO in the Indian space program, but also them. So he started this in India along with many other scientific institutions, be it the Physical Research Laboratory or the Department of Atomic Energy, or like the Space Application Center Ahmedabad, or the Variable Electron Cyclotron Center in Kolkata, and all. So he has been associated with many scientific institutions and their development in India. Okay, not means, and these scientific institutions in their own respective fields are contributing to the Indian society. Not only that, apart from the scientific institutions, he has also been associated with the development of the scientific institutions or industry level institutions like the Ahmedabad Textile Industry Research Association, like how science can be better used in the trade mills or like even in the textile mills to produce better quality and both for the workers as well as produce better quality textile here in India, especially in Ahmedabad. And then his name is also associated with this community science center in Gujarat, named the Vikram Sarabhai Community Science Center. As you can see, he has been associated with very popular political leaders of the time, be it Pandit Jawaharlal Nehru or Indira Gandhi. And also, he has been associated with the you can say, establishment of the first Indian Institute of Management in India. That he believed that project management knowledge is highly important for developing country, and in the future it will produce many entrepreneurs or even institution builders and all. So basically, what why I'm sharing his story is that before we start our today's main topic, is that to take inspiration from his life only, that how in different fields he have worked basically to provide you can say quality life or like improve the life of the common people through science and technology. And that has been more or less the life of Dr. Vikram Sarabhai. And he was the mentor to Abdul Kalam. Okay, like basically Abdul Kalam was a product of Vikram Sarabhai, you can say. So that's what Abdul Kalam became by getting mentored from Vikram Sarabhai. Okay, so this comes why I'm sharing a story is that we have an initiative at Life to and Beyond named the Outreach Sarabhai, where these invited talks or even these invited outreach events or even outreach events that we conduct at Life to and Beyond are done in his name to spread the spirit of Sarabhai as one of the most prominent leaders from the global south working in the space sector or in science and technology to improve the common people's lives and touching their lives through science and technology. Okay, and that's why it's important. So Sarabhai, in its true right, is a story to be lived and also like taking inspiration from. Moving ahead, let's move on from Sarabhai a bit to SEMS Foundation. When I was going through the website of SEMS Foundation, I was glad to see the type of work they are involved in, like child upliftment or youth empowerment or like health, nutrition, and then education, socio-emotional, or even life skill developments and all. Okay. These are some things that is always associated with a non-profit or a you can say non-governmental or like the Section 8 companies and all. And it's quite you can say important aspect of a responsible NGO. Okay. But then why I'm telling about this, it's already been introduced. So it's an important factor to note here that how can space help solve these problems I'll be discussing today. Okay. So these problems can also be solved or like space is also contributing help uplift the people by solving these problems that you can say an NGO or in general means you can say the Section 8 companies deal with. Okay, so coming back to the slide, just a second, I'll just maximize it. I'll make it a full screen. Yeah. Moving ahead, um, I'll I'll try to connect all of these problems to the very topic of sustainability. Our daily life can be the problems of our daily life can be solved if we lead a sustainable life. Okay, so sustainability is an important topic to discuss here, and then I move on to the applications part by part, keeping sustainability in the center point. But I would like to know from my dear audience again, my dear audience, please, can you share a bit about what do you know about sustainability? What is sustainability according to you all?
Sustainability, can I say, sir?
Sure, sure, sure. Please don't call me sir. You can call me Palit and all. No issues with that. Okay.
Yeah.
Hmm.
So I think sustainability is like, you know, using the resources in a limited way.
Hmm.
So,
Exactly.
yeah. So saving the water,
Hmm.
saving city. So this, it's basically resource, like using the resources in a limited ways. That is what
Okay,
is.
absolutely. That is certainly one of the most important factors of sustainability, but not the whole thing. But thank you very much for sharing it. Okay, anyone else in the comments? Anyone? Or even like you can unmute and share if possible. Anyone else in the audience would like to share in the comments? It would be great to make it more
I think it's
interactive.
the use of any particular material so that it fulfills the needs of present generation and also does not compromise the needs of future generation.
Exactly. That is the main definition of sustainability. See, when we talk, thank you very much, my dear friend. So, when we talk about the UN definition of sustainability, see, the basic definition is what Shomojit suggested, and that also encapsulate what Yashika was mentioning in her point. Okay, so see, this particular Earth is a heaven in comparison to the whole of the universe. Okay, where we are living and we have evolved over time, right, and we are still evolving. So, this particular earth is not a kind of ancestral property to us humans that we'll exploit it and like lead a lavish life. Whatever we want, we can do. We can just means conquer everything. Okay, it is a kind of resource that we need to conserve and protect for our future generations. We owe something to them rather than it being an ancestral property to us. And so, considering the needs of the future generation, we should responsibly use and like you can say even produce something in our daily life so that it doesn't cause a menace for the future. Okay, as well as at the same time, is like uh, meet our needs of the present. Okay, that is what sustainability is. So, why sustainability? Quite common. We have all known this. Economic disparities, social issues, biosphere imbalance. These are all frontline news topics that you get to hear or like read in the newspaper and all. So, this is not something that I will go on to digressing. These are problems, but I'll go into the space solutions. How sustainability? Yeah, you can see here the 17 sustainable developmental goals. I hope you all have come across this previously, but I cannot guarantee. Just check this out again. I'll just read it for you so that you have this in mind as I go ahead. No poverty. Shouldn't it be a goal for humanity to solve its problem? No hunger. Good health access. Then quality education access. Gender equality, and then clean water and sanitized water. Okay, and then renewable energy, good jobs and economic growth for all, innovation and infrastructure, reduced inequalities amongst ourselves, sustainable cities and communities where we live in, and responsible consumption, as Yashika was also mentioning, and then climate action to solve the problem of global warming and greenhouse effect, and then life below water, protecting the life below water as well as life on land, and then maintaining peace and justice for all here on earth and beyond, and also you can say achieving all of these goals that I mentioned till now through partnerships and collaborations, because it helps achieve it in a better way. Okay, so these are the sustainable developmental goals as adopted by the United Nations member nations back in 2015 under the Agenda 2030. Okay, this is the wedding cake model. I hope you all have seen at times, or like be it in picture or in TV or in even real life. You can say more than one layer of cake. So this is the kind of model where the sustainable developmental goals with at the top partnerships number 17 help solve problems at the societal or social level, economic level, and biospheric level. Okay, and here we start discussing about space. So space also helps attain sustainability at the social, economic, and biospheric level. And that's the wedding cake model for space sustainability. Let's see how it does. Okay. Again, I'll come to my audience, because more the audience feedback, I can better know what's the general public's opinion about space. So, what's your thought that if space can help attain sustainability here on Earth? Like, is it a waste of time, effort, and money? Any kind of thoughts from you all, and in the comments, or even you can unmute and share. Anyone in the comments? Anyone, please share. Like, what do you think? Like, space has any relevance to our daily life problems, or is it a waste of time and money? Just anyone?
You can unmute yourself and say, I mean, anyone wants to say.
Never mind. We will discuss it further, and in the as we go ahead in our discussion, we will. I think it will be clear enough that how space is helping us solve our daily problems. Okay, here is a kind of summary as I begin in this main part of the talk. That space helps our Earth through kind of Earth observations. Remember, while solving any problem. Okay, I see one answer in the chat. Yeah, urban planning. Exactly, Deepak. Thank you very much. This will be an important part in this Earth observation only. See, to solve a problem, we first need to measure the problem. The problems here on Earth needs to be measured. Like, for example, this urban planning, as you mentioned, Deepak. Then this climate change and all, global warming, greenhouse effect. Then disaster management during earthquakes and floods. And there are plenty other problems. Okay. So how is it measured? Do you think on Earth you can, like, when earthquakes or floods are happening, or even this the worldwide climate change is happening, you can measure it from on ground applications or on ground devices and all? Not exactly. Okay, you only can measure it precisely from beyond the globe, something outside the globe, and that's through satellites. Okay, and that is the first application that comes to your mind or our mind when we talk about space. Their Earth observation capabilities has helped, we can say, solve many problems from space here on Earth, achieving the SDGs and daily life problems. And these are something that I'll be discussing in the next slide, so I'm not going into much detail here. Then space spin-offs. I hope you all know the definition of spin-off in general. Spin-offs are anything that are developed for a particular purpose initially, but later on finds application in many other areas. Okay, so space spin-offs are helping in many sectors on Earth. Okay, then Even space is helping in the health sector, terrestrial health sector, like in our hospitals and like health management here on Earth. Even space is a COVID, like underappreciated COVID warrior. We know police, doctors, army people, even like our you can say cleaning individuals and all those who have been associated and worked day and night during the COVID-19 to help combat the pandemic. We do not appreciate the role of space that it has provided, or like it has the services it has provided to Earth. That is why we have been able to combat this thing in 2 to 3 years, or else it wouldn't have been possible. I'll come to that. And last but not no, this is the second last one. Space also helps maintain international cooperation and peacekeeping. It is quite important to note that amongst our daily problems, war and you can say any kind of warfare activities um, is something that is happening at this point in time when I'm even talking to you all through this webinar. We know what kind of wars are going on throughout the world. Okay, so amid such a kind of imbalance or like world disorder, space is a place where you do not have a choice. You have to collaborate in many cases because their survival comes first, ego comes later. Okay, so in space, many countries that are fighting or maybe rivals here on Earth have to collaborate and have collaborated and are collaborating at the moment. One of the best examples is the US and Russia. Okay, they may have opposite thoughts here on Earth, but they are collaborating in the International Space Station. Okay, they didn't have any choice. But yeah, there are many newses that Russia will be backing off the from the International Space Station and all. But let's hope that it continues. Okay. Nevertheless, there is also one point that we often ignore, that is, we are humans. We are humans and therefore we love exploring and therefore we are curious. That makes us unique to other species here on Earth comparatively. So let us maintain the sanctity of being a human and keep exploring the world and know more about the world through space exploration, because space helps inspire people to know more. Okay, and that with that, I'll end this particular slide, a summary to the upcoming detailed thoughts. There are two aspects to space sustainability. One is sustainability in space, and another is sustainability from space here on Earth. Sustainability in space, like for long term missions, like to the moon or like to Mars and all, sustainable solutions or devices and all, or equipments and all are required. So, that is a completely different topic to be discussed in another set of talks and all. But today I'm going to discuss not about sustainability in space, but about sustainability from space. Why? Look at this particular picture on your screen. This picture was taken by the Apollo 17 astronauts from the moon. Okay, so this is a blue marble kind of picture that you can see. Our Earth is nothing, technically negligible in the vastness of space. Okay, no one is going to come and help us from our own deeds that we are doing here on Earth. So the responsibility of saving ourselves and the Earth and our future progeny lies on us only. So look at that picture again. There are better pictures even, like a point where you cannot even recognize that that is Earth. But I put this particular picture that Earth is important. And why Earth is important, you can see it from space. Okay, that it is in its obscurity, it just is floating in the vastness of space. Okay, so for this particular reason, to save Earth, space also plays no less role. Sustainability from space. Here we go on to discuss one by one that how space helps attain the sustainable developmental goals. Number one, number two, number three, and number six. Let's see how space helps in attaining these four sustainable developmental goals. So the space spin-offs help attain these four. As you can see on your screen, I'll just wait a few seconds for you all to just skim through, but I'll show the pictures and share with you. It will be better even. Like no poverty, zero hunger, good health and well-being, and clean water and sanitization access. These are something that space also is playing a major role, but gets underappreciated or we do not even acknowledge that. Few of the examples are, you see here, space can help map poverty regions here on Earth based on like nutritional status and other reliable factors. One inspiring story I want to share here is that I think so majority of the people in today's webinar are from India, But nevertheless, maybe you all have heard about the politician, the very celebrated politician from Tamil Nadu, Jayalalitha ji, right? If I'm not wrong. So she's no more amongst us. But then the point here is she started many great initiatives like the midday meal system and many other like the Anna Unnavagam. So she was called Amma in India, or you can say a loving mother. So to provide access for the needy, she started this particular initiative of Anna Unnavagam. Okay, this particular NGO during the COVID 19, we know that many needy people didn't get much support because everyone was, you can say, home quarantined and all. Yeah, many NGOs and like people came to support them, but there were, you can say, unequitable distribution of food and any kind of other support. So, clubbing the space data, that is the remote sensing data, plus the ground based data, a kind of map was can be generated based on Earth observations that can actually find out where there are more needy people based on nutritional status of a particular region or other. Okay, so this particular Bhuvan portal actually is the Earth observation, one of the Earth observation database that was not made public till the COVID 19. It is of ISRO, our Indian Space Research Organization. This was made public only during the COVID 19 and is still public. And that's the best thing, that necessity is the mother of invention. Necessity is also the mother of, you can say, making things more accessible to people. So here, the Anna Unnavagam volunteers used the data and the maps where they found out that there were more needy people nearby Chennai and all, and they helped distribute food and other essentials to them, like precisely getting the locations through space data. And that's how space is helping to some extent mapping poverty and also like improving the lives of the poor here on earth. Then coming to the second one, that is no hunger. I think so. We all know that there are many systems that come from space and that we use here on Earth, like the HACCP, the Hazard Analysis Critical Control Point. This is a system that was developed back by the Pillsbury companies in US in 19 is like in the last century when NASA was developing space food for its astronauts, and still is obviously, but it was the initial stage of space food development. So this particular system actually ensures quality check of any food on Earth in the industrial level at the point. So it actually provides for a reliable system to like check the quality of food that we have that comes from the industry. So basically, it was started for space and now is finding applications throughout the earth, improving the food quality or checking the food quality, making quality food accessible to all. Okay. Then there are, you can say, things like hydroponics or like vertical farming or aeroponics. These are some things that were initially like developed for space, because in space there is very less space in the International Space Station or other kind of space stations, and very less resources, be it in terms of minerals or like soil or even like the water and all that can be taken here from Earth. Okay, so with such limited resources, with less wastage, and within a small area of, you can say, place, more productivity or more experiments on plants can be done. So this particular things, I hope you all have come across many startups in today's date working on hydroponics or aeroponics or even like this vertical farming and all, making more food accessible to all just in the limited space and limited resources and less wastage of things. Okay, so that is what space technology can do. Another example is precision agriculture, precisely finding out which land is more cultivable and or like requires what kind of resources in what kind of proportions and all, be it water or minerals, and accordingly it helps farmers as well to know which land to go for crop cultivation and all, and what kind of resources will be required to make that land cultivable. So basically precision agriculture provides for more solutions for our farmers that can improve their work as well as make more food and less wastage of food in our day-to-day lives. Then there is coming to the third one, that is a quality healthcare or health and well-being. Telemedicine or tele epidemiology. These are two fields, and many more related fields exist that actually developed here on Earth, but became more popular in terms of space applications later on, and now is finding more applications here on Earth. Like in the US, it has already been in application for a long time now. In India, most importantly, it was during the COVID-19 only that telemedicine was legalized in our public health institutions. Okay, telemedicine, please note, it is not like calling up your, you can say, family doctor or any other doctor late at night or even anytime and saying your problems and he consulting you with some medicine or other things. Telemedicine is a bit more sophisticated using many devices and other, you can say, technologies to provide real time data of your body vital, you can say, factors and other things to kind of, and accordingly the doctor provides you with consultation and services. Okay, it can provide quality healthcare to the remotest parts where even doctors and health infrastructure aren't there. Okay. So in India, it has already been implemented for quite some time now, like maybe for the last few years. And in US, it has been working, and many other parts of the world, it is popular. The Canadian Space Agency developed like devices like the biomonitor and like a wearable device, like a T-shirt with sensors that can means in real time measure your body vitals, be it your heart rate or breathing rate or even blood pressure and other things. Even there's a device named the bioanalyzer, like that can provide the data of after analysis of your body fluids like urine and blood. That takes 2 3 days. It can provide data within 1 or 2 hours only. So
Excuse me,
you can,
sir. Here,
yes.
this side, Lakshmi, the host. Your slide is not changing actually.
No, no, here it is. I'm in this, but this slide actually contains a lot of things actually. The
Okay,
biomonitor. Yeah,
okay, okay, fine.
it actually covers many things. That's why I am dedicating more time to this. Thank you very much.
Okay, okay. Thanks.
Yeah. So the biomonitor and bioanalyzers are something that still needs to be made portable and like affordable to the common people. But the telemedicine has already been implemented. Okay, like for example, I have a friend from Brazil who is working on a space law project with me and many other people at our company. So he was saying that a satellite of theirs was launched into space by an Indian ISRO rocket. So that particular satellite helps provide tele-education, means through telecommunications and also telehealth to the people living in the Amazon, like or living in the remotest parts of Amazon, where it is inaccessible for people to go or like build infrastructure there. So it's quite interesting, like how space is helping people in the remotest parts and also in the general life. And last but not the least, to the last part of this particular slide is NASA's new space toilet that's up in the International Space Station. As you can is very well guess that it helps remove or extract the hazardous part of the urine and makes it more drinkable. Remember, in space, very less components can be taken. So responsibly, like for example, the tea that drink today, it becomes a drinkable water for tomorrow. Okay, so basically they have shortage of things, so they have to responsibly live their life up there, how many days they live there and do experiments and many other studies and all. Okay, in on earth that time is coming up soon. It's not that it will never come on earth. So why not let's become like more responsible and use devices like this, implement it on like large scale and make more quality, maybe it water or food or health, and even improve the life of the poor here on earth. So these are some of the applications that kind of summarizes that how space helps in attaining or is touching lives in terms of sustainable developmental 1 2 3 and number 4. Okay, coming to sorry, number 4. I was talking about number 6. Yeah, coming to the other aspects of sustainable developmental goals, that is number 4, 5, and 10. These are quite important, like at the social level, how it's important to deal with people and all. More access, more diversity, more equity, and more inclusivity in our daily life. Because maybe we have reached the moon, but if we cannot means generate a sense of respect for each other in our work life or in our daily life, or even make education and like work opportunities accessible to all, then we cannot say that we are living a good life here on Earth, right? As humanity, so space helps solve many of these problems, like in terms of education. Yeah, NASA has many projects. Different space organizations has many projects, not just NASA. Like its citizen science projects, or even its engaging outreach events, or even its contents and all. Means NASA is at the forefront of that. There's no doubt in that. And it's not just scientists, even non-scientists, those who do not have a degree in science, not even like people those who are very very young, like in the school, they can also do projects like they can publish papers and all and help in the space exploration. Anyone can do space exploration, and like anyone can do research in space. So that is what NASA's you can say space education initiative actually encapsulates. And not only NASA, our ISRO has also been associated with many things. Like for example, you can see the Krishi Darshan, the you can say the television channel mainly for the farmers. That was one of the first TV channels in India. Okay, so this is something that was made public through space technology, making you can say television broadcasting available through space technology in many villages around Delhi. It was a project made during that was done during Dr. Sarabhai's time. So till then, we still have Krishi Darshan, and we have uncountable channels on our TV now. But it was a start, and space still helps broadcast TV and tele-education and telehealth and many other things to the remotest parts of India as well as the globe. Yeah, ISRO has also started its space education initiative more actively in the recent times. You can check on its website the virtual space museum, the space education, the space tutor program, and many things are there. Even the Chinese space, you can say, space station is up there now, and not only in the International Space Station, but also in the Chinese space station. The astronauts or taikonauts or cosmonauts, whatever you call them based on their nationality, they are helping in educating people more on earth, or students or general public, by doing experiments or doing things that can educate people in the unique microgravity or zero gravity environment that is quite unique to space. We do not quite get it here on earth. We can artificially simulate it, but we do not get it much on earth. And not only that, this particular session also is an endeavor towards that of educating people and bringing space to the mainstream discussion. Okay, and yeah, I will not ask again to our dear audience, or else it will take much of our time because we have obviously a crunch of time. Never mind, we have a lot of people here on Earth. Okay, you can see the figures, lot of zeros here, but then uh, only around 630 to 634 people have been to space to date. Okay, out of them, out of which 88.7% are male and 11.3% are female. Okay, so I think you can recognize some of the faces on your screen. Like apart from male and female, there has been none from the LGBTQ plus community who has been to space. I mean, like those who have acknowledged that they belong to this community. But later on, there have been many space pioneers who are astronauts who acknowledge themselves from belonging to this community. For example, Sally Ride, the first woman astronaut from America. And coming to the names of these people, quite inspiring people: Yuri Gagarin and Valentina Tereshkova, the first humans in space, or the first male and first female astronauts or cosmonauts in space. Amongst Indians who have been to space, there is Rakesh Sharma, who went along the on board the Russian rocket. And then apart from that, there have been, you can say, people from India, but not necessarily of Indian citizenship, like Kalpana Chawla, Sunita Williams, and Rajachari, who went to space on board the NASA rockets and means as Americans. And also there has been recently in the year of 2021 a space tourist who is an Indian named Shirisha Bandla, uh, who is associated with the very famous private initiative named Virgin Galactic. Maybe you all have heard about this initiative or a company, which is you can say human space flight or space tourist kind of company that is trying to send humans, general public in particular, to the space. So these are the five Indians yet who have gone to space. But then from the Indian soil, soon Indians will be going to space through the Gaganyaan mission that has started last year. The non-human test flight has been done, and a few more test flights will be happening this year. And by next year, the Gaganyaan mission will be going with 3 to 4 astronaut or Gagannauts, as they call it, or humans to space from the Indian soil with Indian indigenous technology. So, if India is successful, India will be the fourth nation in the world after America or US and Russia and China to indigenously, you can say, with to indigenously develop those technologies that can send humans to space. That will be a quite of an achievement, not means even bigger than Chandrayaan or even Aditya L1 and many more. Okay, so I think you all have come across this particular picture where four astronauts have been chosen from three from America or US and one from Canada to go towards the lunar mission, the Artemis 2. That is not a mission to land on the moon, but go like a kind of mission that will go around the moon and come back to the Earth. So NASA aims to send the first female to the moon. To date, there has been 12 men, American men, who have been to the moon, landed on the moon, but America endeavors to send the first female and the first person of complexion to the moon and making it more inclusive, and also non-American like Canada, a Canadian also going on board that particular mission. So this series is coming up this particular decade. So take note of this mission, Artemis mission, to check out the updates on this mission. So space is trying to promote inclusivity or like reduce inequalities in terms of gender or language or region or nation or field of expertise, age group, and promoting inclusion at even different levels, be it less representative communities as well. So there has been many countries from where astronauts have been to space. This is quite not updated at the moment, but I think so. This map will soon be updated on Wikipedia. But nevertheless, not only people from science, but also there are lawyers, there are you can say artists, there are commerce and economy people and entrepreneurs working in space. Space requires all, and space is for all. Okay, so this is a particular note I think our audience should take. Astronauts to date have been generally in the age group of 26 to 46, and with the average age of 34 years. Basically, there's not much of an age barrier to be an astronaut or a human in space in general. Just that it takes a lot of time to qualify and also train yourself to be an astronaut. I think you can understand why it's the case, because no country or no stakeholder would want its astronauts or crew to lose their life in space. It is going to be a burden on the stakeholders, right? A lot of responsibility comes when you send humans to space. So, in this way, at the age group level, also, space sector is trying to make space more inclusive. Not only that, less representative groups like the specially able people, or even people of different complexion, or the indigenous groups of the tribal communities are getting access to space and getting benefited by space. So, more or less, what I'm trying to say, that in terms of maintaining diversity and maintaining or like promoting equitable access and also promoting inclusivity in space, or even on Earth, space is at the forefront. Okay, so that's kind of is relevant to our daily life. And not only humans, there have been more animals or like non-human species in space. The first no life from Earth that has been to space was Laika, a dog, on the Soviet Union mission. But unfortunately, we lost Laika. But remember Laika's life, or many other like humans or non-humans who have lost their lives in space exploration due to unforeseen situations. Remember, they are no less than, you can say army professionals or doctors or engineers who give their life, or even give a substantial amount of part of their life to the service of humanity, because their contributions and their life is worth it, because it has helped expand our knowledge of the universe, as well as will help make safer missions for future humans and non-human species beyond Earth. And finally, to the last part of today's presentation, number 7, 8, 9, 11, and 12, sustainable tech. There has been many kind of technologies that have been demonstrated in space. Like for example, uh, the solar panels that we now use on a daily basis here on Earth became popular not on Earth, but actually when it was first used for a satellite in space. Okay, and that is quite of the success, that not only in terms of applications but also technological demonstration, or most importantly marketing of technologies, scientific technologies. It has been quite instrumental. So in terms of development of sustainable technologies, and even providing growth, GDP growth in a nation, or like providing job opportunities. And it goes unsaid that space is at the forefront of technology and innovation and infrastructure. Then the part of urban planning, as Deepak was telling, that we cannot actually plan cities or replan already existing cities or places from here on Earth. We have to plan it from outside Earth. So building those, or even like means recovering, you can say, lost underground water reserves, or like lost lakes that was previously there in cities and all in all of this, space tech is helping out. Okay. And not only that, responsible consumption and production in terms of like the management of forests or oceans, our mineral resources, or even food, and in any kind of danger, space tech is always helping through the data. Okay, remember, data is important if you want to solve the problem, and space is giving us that data. Now, coming to the very last part of today's talk, that is the last few. Yeah, I did mention about the global space economy, how it's rising and adding to the global economy as well. Space technology, I did mention. And yeah, here is one interesting thing along with the NASA new space toilet. On Earth, just calculate the amount of water we waste while cleaning our teeth during while brushing, be it in the morning or afternoon or evening, whenever we do that. But in space, do you know they use edible toothpaste that doesn't require water to wash off that? You can just eat it, or like it's edible, so no, not much wastage of water. More so that dealing with water in space is quite difficult because of zero gravity conditions. So it's a necessity in space. But can't we make it a product in our day-to-day life here on Earth, so that we can like make less, you can say, wastage of water here on Earth? We can. But then we have to take the step today. Take inspiration from lifestyle in space to help create a sustainable lifestyle here on Earth. As our Prime Minister also says, that lifestyle for nature or lifestyle for sustainability. So, keeping all these points in mind, we must take inspiration from the space lifestyle. Finally, this particular three: climate action, life below water, or life on land. These are some things that we do not often, you can say, we are often caring about, but then let's understand how remote sensing and satellite technology is helping in kind of, you can say, enabling these kind of actions and all, or like protection. See, uh, we talk about global warming and all, and greenhouse effect. Humanity would not even know that this is happening without space technology. So, space technology is actually measuring the problem. For example, this particular picture, as you can see here, is of the nicer, you can say, payload or the nicer mission that is going to come up. It's a short form for NASA ISRO Synthetic Aperture Radar. It is going to be one of the most important missions with regard to studying of global warming and climate change here on Earth, plus also understanding our Earth's crust. And most importantly, the data from this particular NICER program is accessible to all. So if you learn how to analyze the data, any professor, any student from across the world can use it and accordingly report some things that is essential for understanding and taking precautionary measures to stop the global warming effects here on Earth. So that's how space is helping. And this nicer mission is going to come up, like, I think so in the beginning of February or so, like it's coming up soon, as far as I know. So please check that. It will soon be in orbit. And then life below water, life on land, all of these are being monitored by various satellites. For example, in India, we have Ocean Sat 1 and 2, and then there is Resource Sat 2A and all that are kind of managing or monitoring the forest, be it in the Sundarbans or be it in the mountains and all, or be it even in the oceans of ours. So uh, these are some of the examples where space is helping, and that is the case for every country, not just India. Okay. And yeah, the last two of all the 17, as you can understand, it was quite difficult and time consuming to cover everything. Peace, justice, and strong institutions, and even partnerships for goals. What could be a better example than space sector? There's no better example I can think of than the space sector. You see, this particular person, Yuri Gagarin, he throughout his life he promoted that space is for whole of humanity, and that is what the international space station is. This is the international space station. Sometimes you can also like the moon or Venus or Mars, you can also spot it in the sky. You can use Stellarium or Sky View, these kind of free apps to track it in the sky. So this is the biggest and the most expensive, you can say, project of humanity to date. Okay, I hope that it continues, but it is in news that by 2030 it will be like deorbited and all, to move towards lunar orbit and all, because we need to go ahead with the more missions, right? So many space agencies like JAXA, the Japanese space agency, and then Roscosmos, or Russian space agency, then there is NASA, and then there is ESA, and a couple of more from time to time. You can say agencies have been associated with the functioning of this system for many years now. So something means on Earth we couldn't bring together US and Russia on the same page, but at least in space we can. Okay, so that's how actually space is a place where survival comes first. Your ego or your personal problems, or you can say political problems, comes later. So space unites, space never divides. Okay, and yeah, coming to the COVID-19 part, quite interesting to note, because it is one of the problems, or one virus, is one category of virus that shook the whole of health sector and shook the whole of economy of the world. Okay, so COVID-19 is something that is worth mentioning here. During the COVID-19, NASA and the European Space Agency and the JAXA, the Japanese one, collaborated to form the COVID-19 Earth Observation Dashboard to track COVID-19, like how it is developing and all across the globe. Basically, again, I mentioned that to solve a problem, you must be able to measure it. So why within 2 to 3 years we could combat it? One answer is space. Not just a simple answer, but one important answer. So space provided 24 by 7 service to humanity, despite being many delays in its own missions, or like in terms of its human power, or like in terms of its funding and all. Space sectors from across the globe came together to provide, you can say, service to whole of humanity, not just to their own countries. Okay. Then in terms of other examples like Earth observations and all, like the satellite technology, Earth observation, that example of Earth observation dashboard is one of them, where through Earth observations you can track the COVID-19 virus, how it is spreading across the globe and all, clubbing space data with the ground data. Teleepidemiology. Not only just the telemedicine, but also teleepidemiology is important, because you can track the, you can say, virus, or like the patients and like the different variants of COVID-19 through this particular epidemiological study remotely through telecommunications. Then space spin-off products, biomonitors, bioanalyzers. Then like there are ESA's light fieldable laboratories to set up camps, collapsible camps for vaccination and COVID tests. These are some of the examples of space spin-offs that helped during the COVID-19. Then telemedicine, no doubt, means because it was a necessity, home isolation, lot of COVID patients in the hospitals. So telemedicine was one of the only ways. Okay. And in India, it was even legalized. There has been, like, now, if you see the health curricula of India, means you will find telemedicine also as a subject that is being taught to the health, you can say, students, or like doctor, means doctor pursuing, or like the upcoming doctors of India or even the world. So in throughout the world there has been application in America, as I already mentioned, in Europe as well. It has been in huge applications previously, but across the globe it found applications, means during the COVID-19. And one thing that was common between astronauts and us here during the COVID-19 is the isolation part, or like non-connectivity part. That during the isolation and during non-connectivity with many other individuals socially, we did face many kind of mental, means problems or issues, or mental breakdown during the COVID-19, right? So I have gone through that. I think many of you have gone through that. Now, how did space help that? We should know that space has been at the frontier, especially NASA has been at the frontier of human space flight. The data that it had with its, you can say, uh, observance of many astronauts that it has sent, along with many other, you can say, non-American, you can say, astronauts and all. It was made public to the health institutions, so that based on that data only they can provide evidence-based data or advice for any kind of mental issues that are quite relevant for both astronauts as well as people who live in isolation or quarantine during the COVID-19. So that's how space actually helped provide evidence based health solutions to people here on Earth during the COVID-19. Okay, so that's it. Covering everything to COVID-19 case study. Okay, I hope now we acknowledge that how space is relevant to our daily problems, and it is important to acknowledge its effort and also how it can help us in the future to solve those
Solve those
problems.
problems.
Okay.
Okay.
And
And last,
lastly, I'll take a moment to just share about some of the initiatives from India. Like, for example, ISRO is one of them. Newly in space, the organization that serves as the mediator between the government space agency and the private stakeholders in India. Then Antrix and all these are government stakeholders. Then among the for-profit organizations, entrepreneurial organizations are like Dhruva Space, then Pixel, that's an Earth observation, you can say company and all, Skyroot and many more. And amongst the non-profits is obviously Life 21 and a few more that are working together. So not only government institutions, but also non-governmental organizations or private organizations, be it for-profit or non-profit, are required to develop the space ecosystem both in India as well as across the globe. Okay, everyone's role is important here. Hmm. And that's what Sarabhai also envisioned. I'll end my talk here with the quote of Sarabhai. So once he was asked by some media person or a couple of people that what could means, because Indian Space Research Organization began around the time when India was just recovering post independence, like a country starting its space agency in such a, you can say, time of cash, you can say high, you can say casualty, where the nation requires like many other things, is worth noting. And it is not only the great visionary scientists and engineers, but also the great visionary politicians of that particular time that led to this particular development. And today we know where it is. So he said that there are some who question the relevance of space activities in a developing nation. To us, there is no ambiguity of purpose. We do not have the fantasy of competing with the economically advanced nations in the exploration of the moon or the planets or manned space flight. But today, I think we all know that it has expanded its frontiers beyond human applications to moon or like Mars, and even will go to Venus and also human space flight in case of ISRO. Then he went on to say that, but we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the applications of advanced technologies to the real problems of man or humans and society. And that is what he envisioned when Pandit Nehru asked him that these are not the priorities of the nation at the moment. Vikram Sarabhai said that that is why we require space technology or space organization, so as to cater to the needs of the people, be it farmers or military organizations or defense or health and many more. He envisioned that, and today it is coming into a reality. Okay, and that should be an inspiration to be taken by many other nations from across the globe. Those are at their developmental stage or initial stage of space exploration. So with this and spirit of outreach, Sarabhai, I end my talk. These are our social links or website links, and these are my social links and website links or email ID. Please feel free to follow us or like just contact us if in case you are interested in our work in astrobiology, space studies, and applications. And with that, thank you very much again to SEMS Foundation and to the whole of the audience here for your patience and this opportunity. These are the two QR codes for the Beyond Us newsletter that we have free for every month for astrobiology and space studies and application opportunities, resources, and events that we share. You can also support us as a patron. And this is our WhatsApp community group's QR link. Feel free to scan it and be a part. Thank you very much again. And remember that space really is required for our daily problems. Space is touching lives. Thank you very much.
Yes, sir. Yeah, thank you, sir. So, there are few questions to
Yeah.
be answered, which I received in the
Uh,
chat. So, the first one is how remote sensing and GIS technology plays an important role in the application of day-to-day life.
Okay. Any other question related to remote sensing? Then together I can like share that particular slide.
So actually, I will read out the questions so that you can answer it then.
Okay, then I'll go one by one then. It will be better. Okay, just a
Yes.
second. Just give me a second. I'll just go to that particular slide. Okay. Basically, we need to understand what remote sensing like in simple means. Remote sensing, as is in the name, sensing things remotely. Okay. Be it in terms of physical features or chemical features or biological features. So there are remote sensing. There are two types of remote sensing. One is active remote sensing and passive remote sensing. Active ones, what the satellite does is kind of emits electromagnetic radiation and its sensors collects the reflected electromagnetic radiation back from that particular object, and it collects the physical, chemical, and biological information of that particular object as the case may be. And in case of passive remote sensing, the sunlight is also an electromagnetic radiation, we know, visible light or any other kinds of electromagnetic radiation, as we know. When it, you can say, gets reflected from an object and the satellite sensors receives this, it's called passive remote sensing. Okay, so this data is quite rich. Like you have the biological, chemical, and physical data of a particular person or an object. What do you need more to understand a particular situation? For example, disaster management. Like there are many places we come to know that means our army or volunteers have gone to rescue people. How do you think that people in such a means high casualty situation find out that people are captured in a under a means you can say broken piece of building, or means stuck in the flood and all? It's only through space technology. You have the data, it's real time data. Okay, so that is one of them. Then monitoring the waters, or like even monitoring the global, we can say, weather, how the weather is. Like for example, I am from Bengal, and like we know that in Bengal, or even in the coastal areas of India and all, we get struck by many storms. Okay, and in the recent times, the damages to life as well as property has been less. Why is that? We need to note that because the space technology, the data predicts it beforehand, so that at the ground level, precautionary measures can be taken. And remote sensing is the key player out here. This technology can help, has many applications, and has helped many, saved many lives, and helped protect many public as well as private properties. Okay, so that's how some these are some of the examples of how remote sensing and obviously geographic information systems are actually helping out. Means like your you can say where geographically you are located, or where the particular place where that particular thing is located and all can be found out. Okay, and that's how in COVID also it found applications in terms of monitoring of home isolated patients and poverty mapping, etc., etc. Okay, so these are some of the examples.
So thank you, sir. So one more question is how EVO data plays an important role in Indian space industry.
Okay, I think so. I have already answered that. I would not digress much into that because Earth observation means only remote sensing data. Okay, the main factor is that only, and I have given examples of India where it has been applied. So I would not like to extend much on giving more examples. Rather, more questions can be taken up.
Oh, okay, so how space science and industry plays role in spreading the ISRO outreach program?
How, if you could just pardon?
How space science and
Mhm,
industry plays a role in
mhm.
spreading the ISRO outreach program?
In spreading the ISRO out. Oh, how? Okay, okay, okay,
Outreach
okay. Got it, got it, got it. Okay,
program.
let me. Okay, for this purpose, let us go to ISRO's website only. Nothing better than that. Okay. Okay, you can see here that ISRO has many resources on its website in terms of education as well. Hmm.
So,
In this one,
so,
you can
so
find
I'm
out.
doing. So, excuse me, sir. Excuse me,
Yes,
sir. So
yes.
I'm working at ISRO, sir.
Oh, okay, okay. That is even better.
Yeah, I'm working at ISRO. I just want the new thing so I can use in my project. I'm doing in remote sensing and GIS domain in
Oh, okay, 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 okay,
IR
okay.
Dehradun. That's why I am
Oh,
asking.
yeah,
I
yeah,
want
yeah.
to.
In Dehradun, there is this IIRS project, right?
Yeah, yeah. I'm working there only.
India.
I'm
Oh, okay,
I'm co-
okay. That's a
yeah,
pleasure. Thank you for joining.
yeah, sir.
Uh,
Right now I'm doing IIRS ISRO outreach program.
oh,
So
yes,
that's
yes,
why
yes,
I am
yes, yes.
asking, sir. So
Yeah, please feel free to
I'm
call me Palak.
yeah,
It's an honor
yeah, sir.
question from you,
Uh,
sir.
sir, I just I'm working and I'm trying to I'm looking for a project in a space in promotion directorate in
Ha,
Ahmedabad.
ha, right, right, right. Okay.
Yeah,
When you're talking
there
about
on.
in space,
Yeah,
for example, I'll just take an example from Life to and Beyond only. We have
yeah,
this initiative named Outreach Sarabhai, under which we carry out outreach activities on different topics. Like in 2022, we carried out on space sustainability. In 2023, we carried out on means collaborative lunar missions as well as on space entrepreneurship. This year, under our
yeah,
Bhai, when we finish our anniversary on the 8th of Feb, we'll be
yeah.
organizing our Foundation Day event where we are hosting the promotion director, as you may know, Dr. Vinod Kumarji, out there.
I'm
So,
working. I'm working in
yeah,
like
yeah, yeah.
under him only. Yeah,
Oh, yeah. He's
Vinod
certainly an
Kumar. Yeah,
inspiring individual.
yeah,
So,
yeah, sir. He is very inspiring, sir. He
exactly.
like I'm working
So,
I'm following his instruction only. So that's why
right,
I'm
right,
asking.
right. So in
Vinod
India, like
Kumar,
not
sir.
only in India, ISRO is doing a great work, as you already know, in terms of virtual space museum or even like promotion. Like space education has many aspects to itself. Like for example, we know that our Republic Day means this particular exhibit of Chandrayaan or like the Aditya L1 and the Gaganyaan mission and all took place. It is after
Yeah,
many years that ISRO's tableau was displayed. That is also a part of educating people, of spreading awareness about space. Now, apart from ISRO and IIRS and all, there are non-profits like Life to and Beyond or even SSERD, as I know, and those are
yeah,
under space tutors and all. All of them are trying their best in their own capacity to help spread. Means like in our case, we take up unique space subjects, like for example, space entrepreneurship. This year, we are taking up human space flight. Next year, we plan to take up space diplomacy. These are subjects that are less discussed. So, means each one of us has to play our role in this huge space sector. Everyone cannot cater to everything, but everyone can do something. So, in that way, I feel means collaboration as well as combined effort of private or non-governmental organization, plus our very dear or ISRO, as well as collaboration with throughout the globe organization, means I think space education can truly be made accessible to all.
yes, sir. I like he's a promotion directorate.
Yes,
No,
yes,
Vinod
yes,
Kumar, sir. So
yes, yes.
I'm working under him only, sir. He's very
Oh, great.
inspiring, sir.
You can
He's
just
very
join
inspiring.
our WhatsApp community. We will share in a couple of days only about the event that is the Beyonders Open House, where we'll be hosting him on space
Yeah,
entrepreneurship in India, kind of fireside chat.
yes, sir.
Thank you very much.
I'm getting all the updates on my email, sir. So that's
Great, great, great. Mhm.
I'm completely like I'm right now I'm doing IIRS outreach program funded by
Ah, ha,
Department
ha.
of State Government, and after that I'm looking for a project in a space that I'm
Mhm.
looking for some small startup in the field of RS and GIS
Ah,
domain.
ha.
That's it. RS and GIS. That's why I ask you this type of question because I'm exploring right now. This I'm just learning that. That's what I can say.
Yes, yes. Thank you very much for your
Thank you.
question.
Thank you, sir.
Yes, maybe we can move on to the next one.
Yes. Does aliens exist?
Your voice, yeah.
Yeah. Does aliens exist?
I think so. There's some network issue on your end.
1 second, sir. No.
Now it's fine. Now it's fine. Yeah.
Yes, yes. Does aliens exist?
Oh, does aliens exist? Okay, okay.
Yes, yes.
Aliens. Okay, this is a question that humanity has been asking to itself from the very beginning. How can I answer? Whoever asks that question, that is a very, you can say, important question. See, the answer to that is simple. We don't know. That's why we are studying. Okay, means we don't know. Therefore, only we will do more work, right? But then in this vastness, like talking from more chemistry perspective in general, like apart from the more sci-fi or like is whatever is shown on TV and all, apart from the green guys, okay, as I call them, uh, chemistry is everywhere. Chemistry universally is same. So if it is on Earth, shouldn't the probability of it existing somewhere else where it has similar conditions or other conditions be there? It is, right? We just need to look for them, or maybe we are not technologically advanced enough at the moment to find them. But nevertheless, we should keep doing the work. Let's see if we can find some, let's see if we can find them someday. If you ask me, I do believe that they should exist, technically from a chemistry point of view. Okay.
Okay. So next question is, how do spaceships fly faster than light?
Unfortunately, spaceships do not fly faster than light. It is only in movies that we are shown that it flies faster than light. Okay, nothing can move faster than light as of now. But yeah, there are concepts like wormholes and other things that are quite at its theoretical stage. If someday it happens, obviously we can get something that is faster than light. This is what I can say, at least from limited knowledge in this. But I am not a physics person or more of an astrophysics person, so I cannot answer much in detail in this.
Okay. The next one is, how will NISAR study about
Hmm.
Earth crust?
Essentially, like synthetic aperture radar, SAR in itself is a very big topic. Like we can say, a dual. It will use actually dual frequency to study. But I feel like on my part, I'm incompetent enough to share about the details of or like explanation of how it is going to be used, or like how the technology is at the moment, at least. But yeah, in terms of the objectives, as I have learned, is that it will try to study the Earth's crust, plus also monitor and like accordingly, you can say, study the global warming or like the climatic changes here on Earth. And means with the dual frequency feature on it, it is going to cover a lot of area means on Earth, which has not been possible to date. But unfortunately, I'm not an engineer or a physicist that I can answer the SAR technology in more detail as of now.
Again, thank you everyone for attending today's webinar. And if you have additional questions, you can contact us by email. We are happy to provide additional support. Follow us on social media and subscribe to the YouTube channel.